To your last day of boot camp prep, right? Good job on making it until the end, okay? So today I'll go over two questions from last night. I'll do the dog breeder and I'll do the cash savings problem. And then we're going to go dive headfirst into recursion, okay? So without further ado, let me share the screen. Any questions for anybody before I get started? All right. So I have const get dog breeder, right? Whoops. And this is this is supposed to take two things, right? This outer function is supposed to take two things. It's supposed to take a default name and also a default age, right? So I think you guys remember the dog breeder question from like maybe 2 workshops ago. So this is kind of building off of that. So what this is going to do is it's going to define a function inside called dog breeder, right? And at the end of get dog breeder, we are going to return dog breeder, okay? That's all get dog breeder should do. It should return a function dog breeder, and it takes in a default name and a default age. So, as you remember before, this problem should be the same as last time. Sorry, I have something stuck in my throat. So, that means that this is supposed to take a name, and it's supposed to take an age. However, if I don't pass in a name or an age to this function, then it should go not to Steve, but to default name, right? And the age shouldn't default to 0, it should default to default age, right? So if I don't pass in name, then it should be this parameter that I called get dog breeder with. If I don't pass in age, it should be this parameter that I called get dog breeder with, right? Is everybody with me so far? So then I could say if type of name is equal to number, right? So because what am I checking? What if I only passed in the age, right? If I only passed in the age, that means that name would actually hold that number value that I meant age to be, right? So then I could just say age is going to be equal to name, and then name is going to be equal to what? Default name, okay? Which is we get from up here. And this is possible because of closure, right? Then we just return an object with name and age, right? This is the same thing as name, age, right? However, if the key is the same thing as is the same word as the variable name, then we can omit that and we could just do name, comma, age. Any questions on this? Dope. All right. So now we will do const cash savings. Okay? Now, this problem is definitely a tricky problem, right? So there's a lot of things that you kind of need to worry about. So basically the premise is that if I have a function and let's say that function takes like 35 or 40 seconds to run. It's a huge function, right? It takes a long time to run. So I don't want to, but let's say I have to get that information like every other day, right? I don't want to have to wait 45 seconds for that function to run every time, right? So what if I can make my own like program that takes in the argument I called that function with, and since we called it once with that argument, we know what the value was the first time we called it. So the next time, what if we stored that argument and that value in some kind of thing, so I can just get it quickly without running the 45-second function, right? That is the basis behind a cache. So cache savings should take the function that I'm going to be running, right? That function, like if it's the 45-second function, right? And then I will say let cache, and that'll be equal to an object, because if you were looking at me, I said the argument that you're calling with and the value that's getting returned from the function, key value, right? Key value. So you should be thinking object. Then this thing just returns an anonymous function. And the anonymous function will take the arg, right? This is going to take the argument. So basically we could say if cache at arg is equal to undefined, that means that if this is equal to undefined, that means that the key argument does not exist in cache. So that means that we never called callback with argument. So if it is undefined, then we could say cache at arg is now going to be, because this is how you reassign and how you add new key value pairs into an object, right? Cache object at this key, object at this key, right, is now going to be equal to that callback, but invoked with arg. So what this returns will now be stored as a value inside of this cache, right? Then we can just return cache at arg. So if this if statement doesn't run, that means that arg is actually a key inside of here. So we don't want to call this. We don't want to call this. We can just return that object. I mean that value at that key. If it doesn't exist in there, we put it in there. And then we return what we stored, right? Because we have to store it so we don't have to call it with the same argument again. Not a lot of code, but this is very tricky, right? Any questions on this?
What did you say was your hint to know that it was an object that you needed to use?
Oh, when I was explaining to you, like, I was going like this, and then like this. Like, this argument should have this value, right? So key value. That's all I was doing.
And the reason why the row 18, where you're defining the empty object, needs to be outside of the anonymous function is because otherwise, whenever you run the anonymous function, the object gets set to empty. Is that
exactly right? So
okay.
If this was inside of this function, every time you run the function, cache would be empty. Yeah. So we store this object inside of this function. Mm-hmm. And because of closure, every time we run this function, we have access to that object. Mm-hmm. So we can alter that object and add key value pairs to that object. And this is why the cache should be the only thing inside of cache savings, besides from this return statement. And then all of this logic goes inside of your return function. Any other questions? Cool. So, let's get down to business. Recursion. So, before I talk about what recursion is or what it does, I want to explain something to you that is going to be very useful for you to grasp recursion, and something that JavaScript does behind the scenes every time a function gets called, okay? So, JavaScript is a single-threaded language, right? That means it can only run one function at a time, okay? So, like, if I had a function first right? And then I had function second, second, right? So if I have these two functions, right, and I call first on line 39, what does first do? It console.logs I am first, and then it runs second. If I told you that JavaScript can only run one function at a time, how can this possibly work, right? JavaScript uses something to determine which function is running when, and it's something called the call stack, okay? The call stack is what we do to what JavaScript uses to keep track of what function is running at what point in time. So let's run through what's going to happen on this page, right? As we press enter, as we run this page, we're going to go through the code. Okay, we have two function definitions, right? So nothing happens yet. We just define these functions. Then on line 39, a function gets called. So we throw it onto the call stack, okay? The topmost thing on the call stack is the current function that is running. So first is running, console.log I'm first. We'll see that in the console. Then we hit second, invoked. Hold on a second, we're running another function. So that means this goes onto the call stack. While this is on top, because this is now on top and first is no longer on top, first is actually paused. First is no longer running. We can't continue to run first because we have to run second, okay? Does this make sense? Now that second is running, let's run second. We get console.log I am second in the console. Then, nothing, right? Second is finished running. So, we take it off of the call stack. This is no longer paused. Then we'll get first finishing. And after that, first is done, so we take it off of the call stack, right? Does this make sense? It's very logical, right? You run a function, you put it on the call stack. You run that function. If there's another function call inside that function goes on top of the call stack. And the bottom one is paused. And so on, so forth. Until everything is done running and there's nothing left on the call stack. Okay? This is going to be, I'll leave this here for your note purposes later. But this is going to be very important on how we can keep track of things in recursion. So what is recursion? Recursion is when a function calls itself. That's all it is. It's when a function calls itself, okay? So like, let's say I wanted to write something that counts down to 1 and then returns and then prints out done. So like it takes a number, it counts down to 1, and then it console.logs done, okay? So I can do a for loop, right? So I could do like for let I equal 0, I is less than, like, well, if this was a function, right? So function count down, we'll take a num, and we'll do like for let I, whoops. I mean, I equals num, right? We're counting down. I is greater than 0. I plus plus. I mean, I minus minus. Let's see if I can do this with So we console.log I, and then after that we console.log done, right? Oh wait, we have to run this. So if I call countdown with 5, we get 5, 4, 3, 2, 1, done, right? Easy enough. So, anything that you can solve with a loop can also be solved with recursion, and vice versa, okay? So, you might be saying, why should I use recursion, right? Because some problems are actually easier to solve recursively than with looping, okay? This is true, all right? So recursion has its uses, all right? So you have to know what it does. So let's comment this out for a second. And let's write another function, right? Countdown is a function. And this is going to take none. So what do I mean by when a function calls itself? That means inside of here, I will call countdown. This is what recursion looks like. I have this function out here that's called countdown, right? And inside of it, I'm calling countdown. I can do that, okay? This is valid JavaScript. However, what did I do over here, right? I did a loop, and I basically said I is going to be equal to number, right? So I'll console.log the number, right? I'll console.log num, and then we're going to decrement I every time, and that's supposed to be console.logging this, right? So I'll do num minus minus, and I'll throw that into countdown, and then I'll console.log done, right? So we'll console.log 5, then we'll run countdown with 4. Then we'll console.log 4. And then we'll run countdown with 3, right? So this should work, right? No, it doesn't work. It doesn't work. Not minus 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 1. So now we go on forever and ever and ever. And this is an infinite loop. You can make infinite loops inside of recursion, right? So, how do we avoid infinite loops with recursion? The first thing you should do, always, before you start doing your recursive stuff, before you start messing with what to do with the function call, is to make a base case. A base case, okay? That means, when do you tell your function to stop calling itself? Okay? When does this happen? So if I want to count down to 1, do you agree that when the num is less than 1, we stop, right? So we can do if num is less than 1, we can console.log done. Oh shit. Right? If the number is ever less than 1, we can console.log done. Otherwise, we can console.log the number and then call countdown with num minus 1. So now, whoa, we still have an infinite loop. What's going on? Because this is not, okay, if we have this less than 1 here, and we console.log done, we're still hitting our recursive case. So we have to put this in an else, right? Because if this is ever true, that means we will skip over the else, right? So now we have 5, 4, 3, 2, 1 done. There's 2 takeaways from this problem, okay? 1, you have to make your base case, telling your function when you stop calling itself, right? 2, when you do call itself, you have to pass in something that will eventually make the base case true. If we just passed in num, this will be infinite as well, because it will never reach 1, and we'll just console.log 5 over and over again. Okay? So I'll do this with 3, and then I want to show you what JavaScript is actually doing on the call stack, okay? Pay attention to this. So right away, when we hit line 67, countdown of 3 goes onto the call stack, right? So then in the console, we get 3, right? In the console, we get this 3. I won't write it over here. So is 3 less than 1? No. So we skip to the else, console.log that 3, and then we run countdown of num minus 1. So that means 3 is now paused, and we have countdown of what? 2, right? So we throw 2 onto the call stack, and this is now paused. So that means countdown of 2 runs. Is 2 less than 1? No. So we go into this else, we console.log that 2, then we run countdown of num minus 1. So what is that? Countdown of 2 minus 1 would be countdown of 1, right? And now this is paused. These are both paused now, right? So now we run countdown of 1. So countdown of 1 is 1 less than 1. No, 1 is 1. So we go into this else, we console.log that 1, and then we run countdown of num minus 1. So we do countdown of 0. And what happens with countdown of 0? Is 0 less than 1? Yes. So we console.log done, we skip over here, and then we get to line 61, and then this function is done. That means we take it off of the call stack. So now countdown of 1 made it past here, right? We finished running line 59 now of countdown of 0. So that means this gets taken off. And because that was finished running, this was waiting for that to finish running, so this gets taken off, right? And after that was finished running, this was waiting for this to finish running, right? So this gets taken off. And then finally, we're all done. Does that make sense? It kind of does, right? It's a lot to kind of take in at once, but it does make sense what I was just doing. In the slides, there's all these diagrams that'll make that more clear. But what I'm doing here with the call stack, like commenting in call stack and like writing in what functions being called at what time, I really think all of you should be doing that when you're solving these problems recursively, because it'll help you to understand, okay, where is, like, that'll help you debug. That'll be like, okay, now this is running, this is running, this is running. You know what I mean? And always, you see how I did this with the 3? Always, before you run your, when you start debugging your recursive problem, always put in a low number, right? Like, this is just going to do 3, 2, 1, right? Always put in a low input, so you can count the recursive calls on one hand. Like, I didn't want to put like 1,000 in here or 100, because then I'd have to do this like crazy, right? So, any questions on this? All right, cool. So now, let's try one other thing. Let's say I wanted you to write a recursive solution for a problem where you needed that the function takes in a string and it returns that a string of the original except with no vowels in it. So I want you to take out all of the vowels of the string and return the string with just the consonants, okay? But I wanted you to do this recursively, okay? So now we're going to be talking about returning things recursively. That is vastly more complicated, in my opinion. It's harder to reason about than just doing this, okay? So first off, let's save some time. So we'll do like isVal. We'll write our trusty helper function, and this is just going to take a character, and we'll say return AEIOU dot index of car is not equal to -1. So this will return true if this character dot to lowercase is inside of this string. So this will return true if we have a vowel, right? Is everyone okay with this? I hope you're all okay with this. All right. So we have this function here, right? So that'll just be our helper function, so we don't have to write it later. So let's say I have const remove vowels, and this is going to be a function like so, and it's going to take in a string. So if you were to normally do this with a loop, you would say let results equal an empty string, right? And then once we hit something that is not a vowel, we put it in that empty string, right? So that is still what we're going to do. So now, like I said before we tackle our recursive case, let's think about the base case. Before, the base case was when the number is 0, is less than 1, and we subtract 1 every single time, right? If we're dealing with strings now, and not numbers, what do you think our base case should be?
The last letter of the string.
Right. So, or when the string has no length, right? Or if there's one letter. So I'll just do if string.length is equal to 0, if we have an empty string. Then we can just return an empty string. Or, since it is an empty string, we could just return string. Okay? So this is going to be our base case, right? So now we have to think about something else. Now, if we have a string, we have to check every letter inside of it to see if it's a vowel, and if it's not, we put it in here, right? So let's do the first letter, right? So if is vowel, and we pass in str of 0, the first letter. If this is not true, then we can do results plus equals string of 0, right? Like if the first letter is not a vowel, bang is vowel, so if it's not a vowel, then we could just put this into result, right? Because that's what we want to do. So that takes care of the first letter. So now, how do I handle the rest of the string if I'm not looping? What if I did results plus equals remove vowels, and I pass in string dot slice of 1? What is this going to do? That means I'm concatenating to result the return value of this own function with the same string except the first letter. So this will run over and over again, always slicing off the first letter until there's one letter left, and then we'll return an empty string because the length will be 0. Then we can do return result. So if I do console.log of remove vowels and I pass in hello, what I get is HLL. If I pass in P, what I get is HLLP. GH, GF, HLGFP, right? So, before you guys ask questions on this problem, because I know it's a little confusing, let's do our little call stack model, okay? And we'll walk through this line by line, except we'll skip the last O and we'll just do hell, right? So hell, because that's what we're in, right? Recursive hell. Okay, anyway. So we'll do hell, and we're supposed to get HLL, right? So the first thing that happens on line 83, like this is just all function definitions. So that means on line 83 is when we run our function. So we put on remove vowels of HLL, right? So now, what are we doing inside of this function with HLL, HELL, right? So let result equal an empty string. So result is an empty string, right? If the string.length is equal to 0, it's not, right? It's equal to 4. So we skip this, and then we say if is val of string of 0. So what is string of 0? It's an H, right? So if that is not a val, then we can add it to result, right? So this is now plus equals to H, right? So that means result string should be H. Is everyone okay with me so far? Result string is H, right? So now, on line 79, we're saying result, which is this H, is now going to be plus equal to remove vowels of what? String.slice of 1, right? So of L. Hold on a second, JavaScript says. You're adding this to a function invocation. This whole thing should be on pause, and we will put remove vowels on top with ELL, right? So now, we do result is equal to an empty string again, correct? So result is equal to an empty string. Is the string.length equal to 0? No, it's equal to 3. Is string of 0, what is string of 0 now? It's an E, right? So that means that it is an owl. So this won't be true, okay? So we skip this line. We skip this. We don't add it to result. So then we hit line 79, and we say, okay, result, which is an empty string because we didn't add the E, is now going to be equal to remove vowels of string.slice of 1. So that, one second. Remove vowels of string.slice of 1, which is going to be what? LL, right? Because we sliced off that E. So JavaScript's like, okay, well now I have to figure out what this returns. So we'll do remove vowels of LL, right? And what's going to happen here? So now, what's going to happen here is we initiate result again, because this is a new function call. A new function call will initiate result at an empty string. And then we check to see if it's 0. It's not. It's 2. Is vowel of string 0 not a vowel? So is this not a vowel at string 0? String 0 is an L, right? So that isn't a vowel. So this will be plus equals L, correct? So that means result will be L, correct? Is everyone following me still? So result is going to be L, and then we hit line 79. So that means result, which is currently L, is going to be plus equal to remove vowels of string.slice of 1. So if we slice off the first character, we're just left with L, right? So that means that we have to add something else to the call stack. Oh no. Remove vowels, right? Of L. Once again, this is going to mimic this, right? Because it's the same character. It's the same first character. So we initiate result at empty string. We check to see if the length is 0. It's not. If it's not a vowel, which it's not, we plus equals the first character. So that's going to be L, right? So results will be L. Then we say result plus equals remove vowels, and we pass in an empty string. Because if we do a single character dot slice and pass in 1, that means we start at index 1, right? But that means there is no index 1. There's just index 0. So if you start past like how many are in there, you slice off everything, right? So if we slice off everything, that means we'll pass in an empty an empty string, right? But we're still calling this function with an empty string. So that means, you guessed it, we're going to have to put something else onto the call stack. Remove vowels of empty string. So now we have empty string is going to be results, right? But now we hit our base case, and we are finally almost done, okay? We are finally halfway through what happens, because we have hit the peak, okay? We've hit the peak of all these recursive calls. We're at the summit. So result gets defined as this, and then we say, is the string.length equal to 0? This is true. So now we return string. And we skip all of this, right? So so does everyone agree of remove vowels returns empty string, right? Does everyone agree with that? That remove vowels of empty string returns empty string. So if this is done running and remove vowels of empty string returns empty string, we take it off of the call stack and we found out what this returns. This returns an empty string, right? So that means that line 79 in this call of remove vowels of L should be L plus equals empty string, which is just L. So that means line 79 in this function call is done running. So that means we can go to line 80 and this returns L. Remove vowels of L returns L, right? So that means we can take this off because it's returned. It is done running. We take it off of the call stack. And remove vowels of L returns L. So that means line 79 of this function call was waiting to add this string, which was result of its own call, to the return value of this, which returns L. So that means this returns, this means that result is now LL. Then we can finally go past line 79 and return results from here. So if we return this, that means this is done running, and this returns LL. And then if you remember back to when we passed in ELL, we never added something to result. Result was always an empty string because the first character is an E, right? And we were waiting to see what remove vowels of LL returns. Well, remove vowels, I just showed you, of LL returns LL. So that means result is now going to be plus equal to LL. So empty string plus LL is just LL. So that means remove vowels of ELL can finally go to line 80 because we just did line 79, right? So we can go to line 80. So this returns double L. So that means this returns double L, right? And originally, the original function call was looking for HELL. So result was H, and we were waiting to see what happened here. And this is now going to be LL. And then when we finally make it past line 79 and we return results, so we remove this from the call stack, and that's what we get in the console. How's everybody feeling? Took a long time to explain that. So now,
This problem, it's a remove problem using the slice method, right?
yeah, so we remove each letter by using the slice. We remove from the front. If you wanted, you could have, yeah, I mean, since we want it in order, we would do that. If we wanted it, let's say, in reverse order, we would remove from the back and check, we would remove from the back and check string of string.length -1. But we're removing from the front, so that's what we do.
Oh wait, how do you set the strings index order in reverse? Is that the slice method, or am I thinking of something else?
How do you set the indexes in reverse?
Like, you have a string hello. If you want the whole word to output backwards, how do you do that again? I forgot.
You just loop from the back and put it into an empty string.
Loop from the back.
Yeah, like I is equal to string.length minus 1, I is greater or equal to 0, I minus minus.
Say that again. Let I equal 0.
No, I is equal to string.length minus 1.
String.length minus 1.
I is greater than or equal to 0. And then I minus
greater
minus.
than or equal to 0. And I decrementer.
Yeah, so then you loop through the string and you add it to your result, and then you would return it. But that's not what we're doing. You know what I mean?
I was thinking of another problem, my bad.
It's alright.
Reverse string.
So now, so usually I don't really like slides, I'd rather code live, but I think these slides are actually really helpful to understand more what's going on. So we'll talk about the definition of recursion, we'll talk about call stack, count, we'll do that countdown example again, and then we'll do a factorial example, and then we'll do with recursion and arrays and strings. So, and then I'll talk about some tips, okay? So recursion occurs when a function calls itself. Recursion is an alternative to iteration using a loop. In the real world, you may see recursion instead of iteration when recursive solution is easier to reason about. It does help break big problems into smaller chunks, and it's easier to read than an iterative solution, and recursion won't really affect, and you'll see it used when it doesn't affect performance too much, because recursion can actually hog a lot of memory, so it can be like not that good. But machine learning, AI, those are some things that use recursion all the time. And traversing data structures. So line 14, traversing data structures, is what you will probably be using recursion for when you're like halfway done with the actual bootcamp. Okay?
Marco, quick question. For machine learning and AI, I've heard it's better to know data science when you're doing that. Like, which is more important when you're doing that, statistics or the coding itself, or is that irrelevant?
I don't really know. I don't know that much about machine learning or AI. I don't work in that field.
Okay.
Yeah,
okay.
that's good. That's a whole different like monster, you know.
Yes.
Cool. So call stack. Before we talk about recursion, we have to talk about the call stack. So like I said, JavaScript is single-threaded, which means it can only run one function at a time. So the call stack is the structure JavaScript uses to figure out which function it should be running at any point in time. So whenever we call a function, it's added to the top of the call stack, right? JavaScript will execute whatever function is on the top. So as you can see, here's our call stack. We put first on the call stack, and we get I'm first in the console. Then, I'm first is taken off the call stack because it is finished running. Then we run second. Second goes onto the call stack. We run I'm second, and then second gets taken off. Okay? This makes sense, right? Any questions on how the call stack works? Okay. So let's write in a function countdown, the same one we did before, right? So if we just write this function countdown, wait, hold on a second. Yeah, I knew this slide's out of order. Never mind. So we'll do. Yeah, that slide's out of order. Hold on a second. Something's wrong. Okay. Yeah. So here's the other example I showed you with. Forget about countdown for a second. Sorry. So here's that other example I showed you where second is actually being invoked inside of the function first. So when we call first on line 11, it goes on to the call stack. And then I am first is logged in the console, right? On line 2, we log I am first in the console. Then we call second. So second goes on top of the call stack. And first is still on the bottom. And then we see I am second, because second is running, because the topmost thing on the call stack is the thing that is running currently. So then after I am second is logged, second is finished, so we take it off. And first was paused while second ran. So now we see first is finished. Any questions? And we take first off. Any questions on the call stack? All right. So let's talk about countdown. So before there was that, before we did this, right? Function countdown, which takes in a number, you loop, you start at that number, you go until it's 1, and you decrement each time, and you just console.log I every time. So you get 5, 4, 3, 2, 1, right? So let's refactor that solution, writing a function that takes a number and logs it out. So countdown of num, and we console.log number. So we count down 5, count down 4, count down 3, count down 2, count down 1. Now we're not doing any loops. So we still get 5, 4, 3, 2, 1, but we have to manually write countdown 5, countdown 4, countdown 3, countdown 2, countdown 1 every single time, decrementing the argument by 1 each time, right? So every time we called countdown, we subtracted 1 from the previous number. Instead of manually calling countdown over and over, why not have countdown call itself, subtracting 1 from num each time, right? So if we have countdown of num and we console.log num and we run countdown of num minus 1 and we call countdown of 5, what we get is countdown of 5. We get 5, 4, 4, 3, 3, 2, 2, 1, 1, 0, 0, negative 1, negative 1, negative 2, negative 2, and so on. Does everyone see how this works now with the call stack? This is happening because when are we actually telling countdown to stop, right? We get this maximum call stack size exceeded error, okay? And the same error you get when you have an infinite loop using a while loop or a for loop or something, okay? Same thing happens. It just goes down and down forever. That started off so promisingly. Because our function was instructed to call itself every time, the function ends up calling itself forever or until our computer runs out of memory. So let's write a stop condition so the function eventually stops calling itself, right? So here's our stop condition, commonly known as a base case. If the number is less than 1, we can console.log done. Else, console.log num, countdown of num minus 1. So our base case is when our function will stop, and our recursive case is when the function calls itself. So now if we count down of 3, we have 3, and we have 3 over here, right? Because 3 is num less than 1? It's not. So we console.log 3, and then we hit line 9. So countdown of 2 goes onto the call stack, because we call countdown of 3 minus 1, which is 2. So we put 2. And then countdown of 2 runs, so is 2 less than 1? No. So we console.log 2, and then we countdown of 2 minus 1. So countdown of 1 goes on the call stack. Is 1 less than 1? No. So we console.log 1, right? And then we run countdown of 1 minus 1, so we have countdown of 0 on the call stack. Then we have if 0 is less than 1, oh, that's true. So we console.log done. And then we skip this else condition entirely. So countdown of 0 gets taken off. Countdown of 1 then gets taken off. Countdown of 2, and then countdown of 3. Any questions on this?
Is there any reason to do this with an else rather than a while, or is that just equal, the same, pretty much same thing?
Wait, say that again?
Because you could do this with a while loop, right?
Yeah.
So, but is there any difference with that, or just preference?
This is, yeah, preference. Like I said this before, so anything that you can solve using a for loop or a while loop, you can solve recursively, and vice versa. So like, when do you yourself decide to use recursive problems? You'll see later on, pretty much. Like I can't really like there's certain type of data structures that you'll have to deal with later. So going
So what you're saying is we can't completely abandon for and while loops to cheat with recursion. Not all the time.
No, in my opinion, when you're coding on your own, unless somebody tells you to explicitly use recursion, I would just use a loop.
No, but I mean, we could do this recursively with a while loop, right? Because you could just have the condition while, and then have the console log parentheses number, right? So while number is greater than 1.
Oh, like that? That's what you're talking about?
Yeah.
While number is greater than 1. You call it again? Yeah, I guess so. It's a little derivative, right? Because every time you go into the while loop and every time you hit the function call, the function just runs again. And then the while loop is kind of just started over again with a different number. So it's kind of the same thing as an if statement, right?
Right. So there's no real difference. It's just
But
preference.
I think like if you did this with a while loop, I don't think that would work though. Hold on. So if we have this, no, not this. So if we have this, you're saying like instead of this, we do like while num is greater than 1. Then we do console.log num, and then we do countdown of num minus 1.
Yeah.
That's what you're saying, right?
Uh-huh. And then, but then you could have the console log after that, right? Because once that goes out, then it'd be done, right?
So you want me to do it here?
No. The console log of done, right? Because you have to have that there.
Oh,
too.
yeah, right. Sure. So then console.log. I don't think this is going to work, but it might. Interesting. Why is it 2? Nothing else is running, right? Why is this 2? While 5 is greater than 1, you should see console.log 5 first, no?
Right.
What if I pass in a 3? Wait, hold on. No, stop. Oh, I think it just went on so far you couldn't see it. So when we hit 2, when we call this with 2, while 2 is greater than 1, console.log 2, countdown of num. Oh yeah, this makes sense. Yeah, so this is impossible to do with a while loop because we go down, you're right, we do end up calling it with 0 and eventually hit the done, right?
Right.
And then when that function is done running, we go back into the 1, right?
Oh.
And we'll just keep into that while. The while loop is the thing that has the infinite loop, not the recursive. Because this is based off of this, right? So if I did like num minus equals 1 maybe, would this work? Yeah, but it's a little weird. I don't really know what's going on. So I would avoid doing this altogether. Good thought though. I like the creativity. Anyways, so any other questions on this? Okay. 2 takeaways from Countdown. You need to define a base case, okay? And your recursive case must change the input to the function so that you will eventually trigger the base case, okay? Those are the 2 takeaways from that example. You should be thinking about doing these 2 things every single time you encounter a recursive problem, okay? Any questions? All right. So now we're going to talk about returning from recursive calls. So recursion becomes more complicated when the function must return a value. Good practice is to start by defining a base case. Base cases are often occur when there is a single input that expects a simple output, right? So the sum of a single number is that number. So usually a base case will be the same type, should be doing the same kind of thing that your entire function is supposed to do, right? So definitely test that the base case works before you're working with the recursive case. So define a function, factorial, that takes a number and returns the factorial of that number. So if you don't know what factorials are, that's fine. I'll tell you right now. So like factorial is basically itself times every whole number between itself and 1, right? Including itself and 1. So factorial of 3 is 3 times 2 times 1, which is 6. Factorial of 4 is 4 times 3 times 2 times 1, right? And 5 times 4 times 2, right? And so on and so forth. That is what factorials are. So, what if we have a base case here, right? So what can look like a simple input-output that we can use to build a base case, right? So the base case should be if the number is 0 or 1, because as you can see, factorial of 0 and 1 is just 1. So if the base case, if num is equal to 0 or 1, we can return 1, okay? So factorial of 0, factorial of 1, we get 1 and 1. Does that make sense? So now, the base case is set, and we just need to remember that our recursive case has to bring the number closer and closer to 1 or 0, so we eventually hit our base case. So notice an interesting pattern. So 2 would be times the factorial of 1. 3 would be times the factorial of 2. 4 would be times the factorial of 3, and so on and so forth. So if our base case, we have our base case here, right? So our recursive case should be, it's best to write your recursive case using the simplest possible input that will result in a recursive call. So factorial of 2 is going to be undefined because we don't write it yet, right? So let's write it. So recursive case, we know that we have to call factorial again in the recursive case. So if num is triple equals to 2, what do we get if we call factorial again with num minus 1? So we console.log factorial of num minus 1, and we get 1, and then we get undefined, right? Because factorial of 2, if we console.log factorial of 1, we get 1. However, what factorial of 2 returns is undefined. So, recursive case, num must get closer to 0, 1. From that pattern we noticed earlier, we know 2 factorial is equal to 2 times 1. So what if we did the num times factorial of num minus 1, right? And now we see the 2 in here. But we still see undefined. It's still not returning anything, right? So, what if we say let result is equal to num times factorial of num minus 1, and then we just return result here. So we say let result is equal to factorial of 2, and we console.log factorial of 2. And we've console.log result. And we finally get the 2. No undefines, right? Because we say let result is equal to num times factorial of num minus 1, right? So that means result is going to be equal to 2 times factorial of 1. 2, what does factorial of 1 return? 1, right? So 2 times 1 is 2, so result will be 2. And we return it, and we get 2.
Is there a way to do a factorial problem, but instead of multiplying, like adding, subtracting?
Well, factorials are based around multiplication, so I don't think doing it with addition and subtraction would be wise.
I know, but the pattern, like if you're starting with the number 10, but instead of going multiplying 10 times 9 times 8 all the way down to 1, what if it was like a sum problem where it's like you have to do 10 plus 9 plus 8 plus 7?
I mean, I don't, to my knowledge, that doesn't exist. I don't know.
Sure.
I mean,
Okay.
I don't know. You know.
Hey, I think I know what you're talking about. There is a formula for adding the numbers like 1 through 10. It's, I think, 10 times 10 minus 1 over 2. Is that what you're thinking of?
10 times 10 minus
10
1?
times 10 minus 1 over 2. So like 10 times 9 over 2.
Over 2.
I might have an off by 1
Would
error
return what? What does that
So
return?
Would it
10
be like,
plus 9 plus 8 plus 7, etc.
So wait,
Well, that's addition, though. That's not a factorial, though.
Yeah, yeah.
Yeah, I know,
Just
but
if he was asking for some kind of formula for that.
wait. Is it like n times n minus 1 divided by 2, like n minus 1 in parentheses?
Yep, that's right. So if you wanted to add the numbers 1 through 10, that's how you would do it. But that's the formula for factorial.
Oh, I thought you meant how to find a factorial using addition.
Okay.
Oh, okay.
No, like a problem similar to factorial, but instead of multiplying, you're adding instead of multiplying the numbers out.
Oh, okay.
Okay, thank you. Okay. But yeah.
Okay. So now, let's see what happens with factorial of 5, right? So let's see our call stack in this diagram, and let's see it based off our return value, okay? So factorial of 5, oh yeah, this goes down here. It's just a different color. So factorial of 5 gets thrown onto the call stack on line 11, right? So we throw it onto the call stack, and then what does it return? So first we check if it's 0 or 1. It's not, so we skip this if statement. Then we say result is going to be equal to num times factorial of num minus 1. So that means that we are, and that's what we're going to be returning, right? So that means the return value will be 5, because that's the num, times factorial of 4, correct? So that means factorial of 4 goes onto the call stack, because we are doing another function call. So 4, we go num is equal to 0 or 1, no. So then we return 4, because that's the current number, times factorial of 3. Then we get factorial of 3 on the call stack. We check if it's 0 or 1. Then we say 3, what we're returning is 3, that's the current number, times factorial of 2. So then we put factorial of 2 on the call stack. We check if 2 is 1 or 0. It's not. So then we return 2 times factorial of 2 minus 1, so factorial of 1. So factorial of 1 goes on the call stack. And finally, we get our base case, right? So num is equal to 1, so this returns 1, right? So if this returns 1, that means we take factorial of 1 off of the call stack, and then we do 2 times 1, right? So factorial of 2 returns 2 times 1, which is 2. So if this returns something, that means factorial of 2 gets taken off of the call stack, and also this can now change to what it returns, a 2. So factorial of 3 returns 3 times 2, which is 6. So we can take factorial of 3 off the call stack, and this will return 6, right? So factorial of 4 returns 4 times 6, which is 24. So since factorial of 4 returns something, we can take it off, and that returns 24. So factorial of 5 does 5 times 24, which is 120. And factorial of 5 finally returns 120, and we can take it off of the call stack, and we see our result in the console. Any questions on factorial?
I am curious in this example, if someone put a negative number for num, does that make it go on forever? Just curious. Or no, maybe not.
Well, a number, I'm not really sure what would happen, because it would be like negative, like if we did negative 5, it would be negative 5 times negative 6. Factorial of negative 6, right?
Mm-hmm.
And then whatever that would be positive.
Okay, well, we don't have to. Yeah, I was just curious, like, because the base case is set at 0, 1.
Let's check it out.
Yeah.
I don't really know. That's interesting.
Yeah.
I don't know. Let's check it out. Quickly. So if we have like const factorial for this, we have our number. Then we say if num is equal to 0 or num is equal to 1, return 1, and then we can return num times factorial, factorial of minus 1, right? So let's just make sure this works. So console.log factorial of 5. 120, 4 should be 24, 6. Okay. So this is 6, right? What if I did negative? Yeah, so this doesn't work. Okay. We can console.log num to see kind of what happens. Okay. Yeah, so this just doesn't work.
Okay.
All right.
Thank you.
Yeah, no problem. Any other questions on the factorial problem? Cool. So 3 takeaways from factorial. 3. You write your base case first and you test it using simple inputs and outputs. That will make your life a lot easier, okay? Write your base case and test it using the simplest possible input that results in one recursive call, okay? That will make your life very easy as well. Then you test your function against more complex inputs, okay? Like, it doesn't make sense to start testing your factorial function by passing in 100. Okay? Like, pass in 2, and then pass in 3, and then pass in 5. You know what I mean? Don't pass in like 100. And you should try to... Why does it say 3 takeaways when there's 4 things? What is going on? So you should try to use the Chrome's debugger. Okay, so... Yeah... Honestly, you could do that. I didn't really explain to you guys last week what the Chrome debugger really is, so ignore this, I guess. I mean, it is useful, I guess. I mean, I still think console logging everything is the most useful thing you could ever do. So, yeah. Recursion and iterables. You can use recursion with any data type in JavaScript, as I showed you before in my example with the strings, right? If you're asked to recurse through arrays or strings, the base case often occurs when the iterable is empty or has a length of 1. Imagine finding the sum of numbers in an array. So, sum array, and you pass in an array with one thing, 4, right? So obviously, if the array.length is 1, the sum is easy to calculate. The sum is just 4, right? So if the base case required the iterable to have a length of 1 or 0, it must mean that the recursive case has to reduce the length of the iterable with every call. And you saw that with my string example, right? I made the string shorter. I sliced off the first thing every time. This will most likely be true with arrays, okay? Nested arrays can be approached differently, and we'll talk about that tomorrow. Cannot emphasize enough to start with the base case. Cannot emphasize enough to test the recursive case with the simplest possible input, and that will result in one recursive call. Ask yourself, what type of thing should my function return? The base case and recursive case should return the same type of thing, okay? Use console.log as your debugger. If you get stuck on a recursive problem, try to write it iteratively. Try to solve it first with a loop, okay? And then maybe convert it to recursion, right? Sometimes that can help as well if you're really stuck. It can reveal the inner workings of recursion just to see how you would normally do it. So, recap, we talked about recursion, the call stack, we did some examples. Yeah. Now, today's the same schedule as yesterday, right? We stop at 1, we have the hour break until 2, and then we do recursion part 2. I just want to emphasize that recursion, what we learned in recursion 1, that's it, okay? There are no more tricks or loopholes with recursion. What you know now is how recursion works. Recursion 2 is basically how we can use recursion to tackle more advanced problems with nested data structures, like nested arrays and nested objects, okay? But recursion is going to work the same. It's still just calling a function, okay? Calling a function calling itself, okay? So, any questions before you start the workshop? Okay.